Good afternoon and welcome to this interesting session titled What is Love? Apply machine learning to help win the hearts of your customers, hosted by Next 100 Club and Google Cloud. This is Sangeeta Thakur Verma from 9.9 Media, who's presenting this seminar along with our expert. Before we begin this session, let me briefly introduce the topic to you. We all know that understanding customer sentiment is critical for business success. But analyzing customer feedback manually for emotional cues can be extremely time intensive, ineffective, and potentially misleading. In this session, we will learn how Google Cloud serverless, big data architecture, and machine learning can help businesses understand customer sentiments at scale. We have with us today Kunal Dev, who will explain the fine points of understanding customer sentiment. To introduce Kunal to you, Kunal is a customer engineer at Google and an open source developer. Prior to that, has served in various engineering roles at Sun Microsystems and VMware. He has contributed to many open source projects including KDE and OpenMoko. He also loves to write about open source and has contributed to many technical portals and magazines including DZone. Open source for you and Linux users and developers. So welcome to you, Kunal.
Thank you. Um, so what happens these days is customer satisfaction everybody thinks is important, but they all have different ways of looking at it. And what I'm trying to get going by this presentation is to understand a little bit deeper about our customers and then do the right thing for our customer, yet keeping our business growing. So since everything revolves around love, love is one of the most common or fundamental elements for us. Uh, so let's go with that, right? What is love? And there are like again different philosophical takes on it. One from Shakespeare is like it is an ever fixed mark that looks on the tempest and is never shaken. Another one is an evolutionary necessity for parents to act contrary to their own best interest in order to protect uh, their progeny. That's like very methodical and some would call a robotic answer to what is love. And the other one, which is like little bit balanced on the Shakespeare side of things, and the robotic but accurate is from Aristotle, which is love is composed of a single soul inhabiting two bodies. I will call it even more romantic than say Shakespeare. But to fundamentally understand what is love, it is like two things: trust and joy. The reason why we want to understand is to get to the components which will help us drive love from our customers. So think of it like this. So we have something called wheel of emotion that was created by Dr. Robert, which explains love and other emotions as combination of two other fundamental emotions. So for love, it is often trust plus joy, and awe is often fear plus amazement. So it's like the positive kind of amazement. And then contempt is like anger plus disgust. And if you look at the full circle of it, it's like that combination of things, right? So and and the emotions that I'm talking about often is at the intersection of those two. um, so that is where love sits in, joy, trust, and if you go one level up, there is like serenity and acceptance. And same goes for awe, and then there is a delicate balance to striking that. So I've talked about all that. What does it all mean? So it's what we call emotion arithmetic, and you can use it to get ahead in business. Um, we all have received notifications from an app or in a service that we use, right? But How those notifications have been sent decides whether how quickly we'll be engaging with them or not. Some apps or services constantly bother you, um, to trick you into using their services more and more. Do you think that's the right approach? I don't think that's the right approach. Some services trick you into coming to the first page, then bombard you with like various dialog boxes, which actually sits on top of the content, to get more details from you. Is that the right way of doing it? So that's not the right way. That I call those brute force way of doing things. And if you are the only player in that market, you can get away with that. But if you are someone who wants to do right by the customer, it is important to understand that exact sentiment of that customer at that point in time. So I'll give you an example. For example, let's say you are a food delivery company. If you are able to detect and predict the patterns of your customer, when they are hungry and when they usually order food, rather than applying a universal algorithm which you think is the right, when to send the algorithm, there will be a day and night difference on the user making a purchase on that app. So if I am like, let's say, I always order food during 3 o'clock in my office, and if I'm looking at my phone and you send the notification at that particular amount of time, I won't be annoyed. I will even thank you for actually reminding me of that. So those kind of thing matters, and this is one of the things that we'll be talking about. But the gist of it is like how to better take care of our customers, at the same time grow our business and do fundamentally right by our customers. So there are like two stages of things. One is like pre-sales, when you first meet your customer, and this could happen in several ways, and I have few scenarios for that in the next slide. That also gives you uh, some fundamentals about how to get that data and how to use that data into making other decisions based on uh, data basically. By the way, this I did not mention going into this. This is supposed to be an interactive session. So if you feel like you have questions, please do put it out in the chat windows that you have around you. So let's talk about three such customers journey. In this case, what we are talking about is a company that sells paint, typical paint that you'll use to either paint your house or furniture and things like that. And I have like three use cases. So on top, what is happening is the user visited a blog, spent 20 minutes reading, and they had like three visits to that blog, searched for paint rollers in Google, saw ad for paint brush campaign, visited website to buy paint. Then the question is, already purchased paint, is it a target for add-on sales or not? There is another use case where a guy came in, visited a blog once, searched for cheapest place to buy paint in California, did not see an ad on the paint discount yet, visited the website, spent a lot of time reading content, but it did not convert into sale. What does that mean? Is it a high value customer? In third case, in the third case, the customer has not visited the blog. They did search for paint, saw a banner ad, visited the website with intent to purchase. How do we, take it further and help the customer to trigger that purchase? So you see, there are like various steps in it for you to make decisions. We often ignore these things, but if we are thinking in terms of how we use data to make decisions, gathering data from all these points will be very helpful. My whole point of showing this was to give you an idea on what all various data points might be interesting to you when you want to better understand your customer. So post sale, what happens? You need to have like an emotional connect. So let's say you made that sale using one of those techniques. The customer has come and purchased it. What's happening after that, right? So there is like pre part and post part. So in post, let's say they have purchased something, in this case skin cream, but there was a 5-star review on it. Now on the face of it, this is a 5-star review, which you will see and treat it as like very good. But if you are to better understand the customer, you have to take another look at it. So let me read it. I'm so glad I got this product as a sample, because otherwise I would have probably overlooked it, especially for the high price. My skin is tricky. In some areas, it's very dry, but I still get oily during the day and my skin is easily congested. This product does a great job at evening out the skin tone and reducing texture. My skin feels more hydrated and less congested. The only thing really hate is the price. It's too expensive for my budget, and I'm worried that I won't be able to afford it going forward. However, I am hopeful that they will ship more affordable packaging soon. So, what is happening is there are two things: the sentiment of the document and the magnitude by which that sentiment gets applied. So overall, this complete document has zero point 0.3 sub sentiment, which is not bad. It's like quite good actually. But if you were to distill it out, how the whole thing would look, um, you have places where yellow, so really hit this price. I'm worried that I won't be able to afford it. These things, given the negative points, will give you the exact feeling that the customer is having. Now, I'm not saying that reading this review, you have to make your product more economical or cheap for the sake of it. This is just an indicator of what the customer is feeling about it, right? Maybe you need to do a better messaging around your product, or maybe you need to educate your people more about why this is more expensive rather than thinking it's an expensive product. But this data point helps you do that rather than thinking like in one block that this is a positive statement and cutting it short. So typically, what we have seen right now, at least what I have seen in most of the website, is you say, I need to find a product. In this case, my acne is acting up. I need to find a new product. They search for products. They get results by top rated. So it's like the users who have rated the products. The user spends 15 minutes reading the user comments, move to the next product and repeats the process, makes the purchase and ships the product. And this is the way it is for most e-commerce websites that you go today. But let's see what happens if you follow the same process. Now, this is the review of one such customer who has purchased a product using the methodology that I have just shown you. The customer says, now don't get me wrong, I love this product. I have used this for a month now. The beginning results were pretty dramatic. I used it as a mask for my first use. It definitely tingles and may even slightly burn, but for someone that has always struggled with acne, I will deal with a little temporary discomfort. I have only used it as a mask to X and have been using it in the morning before moisturizing and makeup application. I really take good care of my skin and definitely notice that I am uh, plateauing with a good genes. I still have some issues I was hoping for this product to solve, but I'm comfortable with saying it's a good product. I'm bummed about its $100 five, but for combination acne prone skin, it's worth giving a shot. Now, on the face of it, this looks like a nicer review, but have we, if we would have tuned our search result based on exactly what the customer is asking for and what kind of pain and struggle they are going for, what kind of economic profile that they belong to, a different process could have been implemented, which, by the way, would have given us an excellent review. While this review is not bad, but a review that makes sense for that customer, like all happy rather than being unhappy about few critical things. It's not difficult to achieve. So let's look at what that process may look like. So in that case, we will incorporate sentiment as well in the part of search results. So user has gone ahead, they have a concern, they search for the product. Now results are ranked by a composite of sentiment and effectiveness. So now we are not just looking at the user reviews, but we are also looking at the sentiment of those reviews coming in and then populating it. The user just spends 5 minutes because now the user is only looking at right comments, not just all comments. Because what will happen is you're buying a product, but then you are looking for a comment from that category of people, right? So for example, if you're buying a TV, if you are not if you are a gadget nerd like me, you would want to read reviews from other gadget nerds like me who will talk about pixels and color accuracy and RGB configuration and things like that. Whereas my friend who is not much into TV but would like to have television, he would be interested in looking at reviews from folks who share the same emotion. So, for example, how large the TV is, will it support his current set-top box, will it work with XYZ and things like that. So you see, for the same product, very different kind of reviews can come in, and the same emotion of those reviews could actually affect the rank of the product as well, rather than just going blindly on user reviews. So you move to the next product, repeat the process, and this would hopefully will give you a better path into a better purchase, better reviews, and better enablement for your customer. So how do we do this? So now I have put in the path on what's the right way to achieve it, but how do we get there? So you can do personalized online retail, you can do real time gaming personalization, you can do effective marketing campaigns. These are all various things that will help you get there. But what it is practically, it's actually a big data problem, because now what you're doing is you're not understanding emotion of one or two customer, you are now doing this at scale, and getting this right is also very important. So this actually gives us a segue into how to do this on Google Cloud Platform right now. So what happens is, in these kind of scenarios, you need a platform where you can iterate quickly, because a lot of experimentation would be going forward towards this, and you would want to fail fast and get to results quickly rather than spend a lot of time in managing infra and setting up stuff. So an experiment wouldn't be good if just the setup of experiment takes 90% of the time and only 10% of the time just doing that experiment. So this platform enables you to do it the other way, where the setup takes only 5% of the time and 95% of the time you are building that platform. So in this case, what I'm showing is we have various data sets, like let's say Google Ad Manager, Google Analytics 360, AdWords, or you can also use third-party data sets from Salesforce or Facebook. We are loading it in our storage platform, in this case BigQuery, which is a petabyte scale data warehousing system, where you don't have to worry about whether you are storing 1 MB of data or 1 petabyte of data, and you don't have to do a single configuration to get there. That becomes your central source of truth, and it supports SQL on top of it. So people who are comfortable with SQL can continue uh, going through that data at large scale. What traditionally has happened before is people who are good with SQL, the moment it comes to big data processing, we often discard those folks, and we need to hire big data folks. That is not the case in BigQuery. You could as well use your existing SQL and SQL expertise to get it here, because you don't need to set up Hadoop clusters and things that require those kind of expertise. So here we are saying we already have a data warehouse to go with. You just bring your SQL skills and use it. Data storage is one part. So all these sources connect very well to BigQuery and will give you the data about what your customer is doing. Second part is processing that data. Uh, Most of the time you would have heard, if you can pre-calculate, don't query it in real time. That would give you the best query performance. That is one of the applications of doing an ETL, because ETL will allow you to do those kind of processing. The other thing is sometimes you may want to enrich your data from like multiple sources. So you are getting ads data from here, but let's say your own website, or probably you have physical stores which are tracking the customers as well. You want to combine that data, build out a single view. ETL process could help. So here we have a product called Data Prep, which runs on top of Cloud Data Flow, which gives you a machine learning assisted way of cleaning and enriching the data. So, for example, if you are using data which has comma after two zeros rather than three zeros, and if somebody has uploaded data which has comma after four zeros or three zeros, something like that, it will automatically predict it and will tell you to use the uniform schema that is already present in the data. And it is also user friendly and can be used by anybody who can just work with a user interface and element. So what we rely on, like, you bring data domain knowledge, but you don't necessarily have to go and learn Python or anything to get there. Once you have modified the data, you can process the results again into same kind of storage, something like BigQuery or cloud storage. And then you have various layers on top of it to do other stuff. So for example, you can do visualizations on the results that you have seen in Data Studio, Tableau, or Looker. Your data science team can directly use Google Cloud Machine Learning and Cloud Data Lab to run experiments, run inference, build new models. And you can also use TensorFlow. Now, not everybody needs to learn TensorFlow to use this platform. What we have done is we have implemented machine learning into BigQuery as well. So if you want to do, prediction, if you want to do clustering, so for example, if you are storing details of all the customers who have made purchase on the website, and you just want to predict who are the returning customer who will purchase it in the second try or third try, those kind of use cases can be directly solved inside BigQuery. You don't even have to go through this complete path to get there. So there are like a lot more ways by which you can generate insights now. So this is one of the ways of looking at how data warehousing has been driving tomorrow's business. So in 90s we had like classical data warehouses where it would they will help you data driven business. In 2000s, business intelligence based tooling has formed. Now we have BigQuery, which basically says you just bring your data and everything else we will take care of for you. Tomorrow's foundation is we want to make BigQuery itself to give you machine learning based results for you. And that is exactly one of the examples which I was giving. So if you know SQL, or your team knows SQL, we are extending the syntax of SQL to do something like create model, predict. They can use this in SQL fashion itself to get machine learning from BigQuery directly. So no need to move data from one source to other. No need to do complex data science related transformation inside BigQuery. Everything can be done in just one fundamental single source of truth. This is something more about BigQuery. So like I said, it will scale from 0 to petabytes. And it also accepts a mode called streaming mode. So let's say if you have transactions happening in real time and you want to make sure that all the queries that people are running on that data set are always updated with the latest data, streaming mode can be used. And best of all is standard SQL works. So often what we see is, in traditional approach to these things, we have different products that does different things. Unfortunately, we cannot change that. A CRM software, an ERP software, a billing software, an inventory system, or a POS system may or may not be the same, right? So, bringing a holistic view of the these complete data sets become difficult, and that is what the whole serverless approach helps you get there. Now, in the next couple of slides, what we have is bunch of products in action on what they're doing, to give you some sense of what they achieve. Post that, we'll have a quick demo as well. So this is like how to capture data automatically into BigQuery. So as you can see, we support YouTube, DCM, AdWords, everything, and you just configure that and you add that as a transfer, and then you can just add that data in. This is the ETL piece which I was talking about, how you can transform data using a graphical interface, which is, by the way, machine learning assisted to get the data in the right format, which you believe is good for the business. So what you see here is exactly happening that. This also allows you to combine two or more data sets and then put it in a new data set inside BigQuery. So that also allows you to roll a self-service model on existing data warehouses, where you can just have like teams who will have access to the single source of truth, and then using their business knowledge, they can build their own islands of data warehouse, which can be used for various business applications. Now, in this case, what I'm showing is running on a normal SQL query that gives us some result on a large scale data that has been just imported via Google GA360. This is application of TensorFlow to apply machine learning to categorize or basically segment our customer into different areas. So you can see work, housework, household care, leisure, and these are updated in real time as the data comes in. So Cloud ML Engine and TensorFlow, which is used to do this, supports good integration between each other, including the real-time use cases. So it is very easy to get there. This is another one showing, so now you have applied machine learning, now how you can use a visualization tool to show this data. So this is basically what you're seeing in Data Studio, where we are trying to make sense of the cluster micro segments, as well as going through the insights that we have available inside the tool. So these are fairly easy to do. So if you are to do a POC on this today, you would be able to get this done probably in a day or so with like the starter packs that we have available. This is the static one where we just see what's the sales transaction data is happening, what's the details from Google Analytics 360, and what's happening in the double-click campaign manager. This is another one on how a recommendation engine could be built. In this case, what we are looking at is like various diagrams and their intersections of it. So if somebody gets product C, what's the probability they would be interested in product E or A? If somebody gets product B, what's the interaction? What's the probability whether they will like product D or not? And then we have the data that shows the truth about how much sales has happened on those data lines. Right. This is again people who are data engineers would like to work directly in Python notebooks. Data Labs is our version of Jupyter Notebook running directly on cloud. And in this case, what we are doing is connecting to BigQuery, and then doing feature engineering using TensorFlow and ML Engine. So you can see a BigQuery import statements on the top, and then a TensorFlow import statement at the bottom. So before we go into Q&A, let me run a couple of stuff for you. So one of the aspects which I talked about here is understanding what the customer has said, right? We have a product which is called Cloud Natural Language API, Natural Language Processing API. So where what you can do is you can just take the reviews that the user have posted and put it out there and directly click analyze. And what that will get you is basically what was actually being said in that text. So for example, you also have entity level sentiment. So how people felt about the entities that were mentioned inside the sentences. That is a very quick way of applying machine learning to your custom consumer reviews or complaints or any comments without building a full ML engine yourself. Plus, it does a couple of other things as well. One of my favorite features does a nice syntax tree for you, so it will help you understand what's the verbs presented there, what's the nouns presented there, and things like that. And it has nice way of adjusting it. So if you're building a brute force kind of algorithms where you say yes, nouns are the product names because typically they are, and then the second probability of that is like adjectives and things like that, you could go ahead and build that as well. um, Another aspect of it is, let's say the natural language system that we are showing is not enough for you and you want to build your own classifier into it. So uh, what I have done is, there is a version of AutoML called natural language, and I have trained it with a data set uh, which basically contains a newspaper article title and then the label. So what is the news source for that article? And the use case here is I want to detect the actual classification in which they should go. So for example, in your business case, you want to detect comments which probably reward more purchases, comments which are not good for your customers, comments which takes down the business, comments which really helps business grow. So these are like four classification that I have talked about. But in this case, all we are doing is we have just bunch of news sources, and we want to predict which news source belongs to which title, which headline belongs to which newspaper. So as you can see, there's like bunch of it. We have one from BBC News, um, BuzzFeed, New York Times, and all of it, right? You can click on train to see I have already finished the training, and you can see what's the precision and recall of these machine learning model. And precision is basically how correct we are when we are doing prediction, and recall is how many times we are actually returning the results. So both are important. I mean, like, you can be correct, but if you're not returning results, aka your recall is not good, it is useless. Or if your recall is good, it means that you are returning results, but then the accuracy, the precision is not there, it is again not useful for me. So you need to have both the things in balance to build like a right model. And you see we are doing fairly good here. There is also something called confusion matrix, where we tell you how quickly we get, or how often we get confused from one result to another. So for example, articles from New York Times, we are like most we are getting confused by 18% with Wall Street Journal. So this will give you a nice overview of how your algorithm is performing and where else you can improve on or anticipate the problems might come in. So what we can do is then do predict. What I did for this is, this model was trained, I think, more than 15 days ago. This is today's New York Times article about the Supreme Court nominee. This is nothing. So there's no political angle here. I'm just picking up a news. Uh, Let me just click it so that I can copy it easily. So this is the title, and I'll copy this, and let's see if our model is working properly. We'll click predict, and you can see with 70% we are able to tell you that yes, this article would be from New York Times. So this is like a little bit going into the future. because when we trained it, we have never seen this New York Times article. This is like today's article, but yet with 70% accuracy, we can classify it properly. So this gives you a sense of how, if you are to build your own classifier, how you would do it in AutoML natural language. We'll have entity detection here as well. So let me stop it there and see if anybody has questions.
Thank you, Kunal. This was extremely interesting and amazing concept. And I was just days looking at your presentation. Now it brought some questions to my mind which I would like to ask you, and I'm sure that this will help bring more clarity on the topic for our audiences as well. Number one, can I install BigQuery in my own data center?
Right. Unfortunately, BigQuery is a fully managed product. So basically, you don't have to install it anywhere. It is provided as a service. So you use it directly, but it can't be installed anywhere. It's a managed services. Even when you're using it in cloud, you're not installing anything. You're not even configuring nodes or anything. You're just loading data and running queries.
The second question I have for you is, I don't have a lot of data to train ML models. Will it work for me?
So we have ML APIs which do not require any training data at all. The one I have just shown is Google Cloud Natural Language Processing API, where I was analyzing the emotion of the customers. We also have Cloud Vision API, Cloud Speech API, Translate API. None of these ML models require any data, so it would work fine. But like I said, it will be based on the data that we have trained on. So you have to make sure the use case is right for you.
My third question, I get that you have ML APIs like Vision API and Translate API where we don't have to bring any data. But is there an option where I can build my own version of these APIs using my data but not build the model myself?
Okay, so we good question. We have something called AutoML, where, and the demo that I was showing now was for AutoML NLP, where we use a machine learning technique called inference, where we use Google's own models to build a customized model for you using your data, so that you don't have to build the model, but you have to just provide the data, and now that will work for your business case. So AutoML is a good option for you.
So how much time it will take for my team to learn all this?
So at Google, we have this philosophy of keeping things simple and easy to understand. Since most of the components are managed, so people would not be learning anything that is not useful in doing their job. So for example, they won't be learning how to configure clusters or setting up Hadoop or things like that. The only thing that they need to be knowing is like SQL is like the hard tech thing that we need. Other tools have like a nice graphical user interface. So I would say not a lot.
So thank you, Kunal.
Thank
I would like to thank all our participants for sparing their valuable time for this session. And I'm sure that the takeaways from this webinar will help you understand customer sentiment better and develop a strategy around it. But before we leave, I have a small request. When you close the window, you will find a short feedback form which will pop up. We request you to spare just 2 minutes to fill it up. Your feedback is valuable to us as it helps us understand your requirements better and tailor our offerings accordingly. Thank you all once again. Thank you, Kunal.
thank you.